In the 11th question, we have sum of first P, Q and R terms of an AP are A, B, C respectively. Prove that. We are supposed to prove some complicated expression over here. Sum of, the person is saying, sum of the first P terms, Q terms, R terms of an AP are this. So, SP is equal to A, SQ is equal to B, SR is equal to C. This is given, right? And we are supposed to prove something. We'll prove that. But first, let's write these expressions. SP is equal to A. This will be P by 2 times first term. Let's take, let AP is A plus D, comma, dot, dot, dot. Since you have already used small a, we cannot use small a for the first term. Let's use capital A plus capital D. So this is 2 times capital A plus number of terms P minus 1 times capital D. This is the value of small a. What is the value of small b? This is Q by 2, 2a plus Q minus 1 times capital D. What is the value of small c? This is R by 2, 2a plus R minus 1 times capital D. This is what we have. Is that okay? Yes, that looks pretty much okay. Sum of first P, Q and R terms of an AP are A, B and C respectively. Prove that A upon P times Q minus R, B upon Q times R minus P and C upon R times P minus Q. That's what we are interested in? Yes. So let's focus on A upon P, B upon Q and C upon R. That can be found easily, yes. And A upon P is equal to this complicated looking expression, but we can multiply that with Q minus R and see where does that take me. Yes, yes. So now, in that expression, LHS is equal to A upon P, or what we can do is, let's do one more thing. Let's multiply A upon P with Q minus R in this expression only. Okay. Instead of writing the LHS, because that will be a long expression, what I'll do is A upon P, this is A upon P times Q minus R. Therefore, this is equal to, with the help of this first one, this is equal to, you have A over here, 1 by 2 goes inside, Q minus R times 1 by 2, in the bracket you have 2A plus P minus 1 times capital D. This is what you have. Okay, and what does that give me? Okay, this will be A times Q minus R plus P minus 1 times Q minus R times D by 2. Please take a look at this. This is what you get. This expression is equal to this. Half times Q minus R multiplied by 2 will be this. Half times Q minus R multiplied by this will be this expression. Now, the next expression, B by Q times R minus P. Similarly, will be A times R minus P plus Q minus 1 R minus P times D by 2. This and C. C by R times P minus Q will be equal to A times P minus Q plus R minus 1 times P minus Q times D by 2. And now, we can add these three, right? Adding. Let's call this 1, 2, 3. They will become 4, 5, 6. So adding 4, 5 and 6, what you get is A by P times Q minus R plus so and so terms dot 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 will be equal to capital A times Q minus R plus R minus P plus P minus Q. You see, all of these are in cyclic order, right? So they will get cancelled. Yes. So coefficient available will become 0. Similarly, for plus D by 2, what do we have? You have P times Q minus R, P times Q minus PR, that's what you have, and you have minus Q plus R first of all, right? Multiplying these two, there will be 4 terms. QR minus QP and minus R plus P is what I have. Then you have plus RP minus RQ and minus P plus Q. There will be 4 terms. I have written them in this manner so that you can easily see them getting cancelled. PQ minus PQ, QR minus QR, PR, PR, Q, Q, P, P, R, R. Everything gets cancelled. Yes. So that tells me A by P times Q minus R plus B by Q times R minus P, this term, plus C by R times P minus Q. This whole left hand side is equal to 0 on the right hand side. That's what you see with this, and this is what we wanted to prove, right? That's the complete proof of this question, as you can see over here in this solution. That's all. Yes, that's all for this 11th question over here.